In the remaining parts of today's lecture, we are going to solve several previous SOA questions on chapter 3. If you have the textbook, those questions are on page 111. Here we have 5 questions. I'm planning to use about 30-35 minutes to finish this part. Let's begin with the first one. We have aggregate, which is distributed as a compound binomial. The primary obviously is binomial. The secondary has a discrete distribution. It takes values 1, 2, 3, calculate the probability that the aggregate is less than or equal to 4. When you have this kind of question, well, the distribution of x is discrete, like in this case. So obviously this is a discrete, right? So if you want, you can put everything in a table like this. Probability 1, 2, 3, 0.4, 0.4, 0.2. So obviously this is a discrete distribution. So you can apply, the first method is to use the probability generating function. So n follows a binomial. That means the PGF of a binomial will be 0.2 t plus 0.8 to the power of 9. And for the given distribution of x, we can easily compute the probability generating function. For the first one is 0.4 t plus 0.4 t squared plus 0.3 t cubic. Okay, that is because for any random variable x, the PGF is the expectation of t to the x. So that is the definition. That is why I can directly write down the PGF of x. Okay, so given this is a compound model, the PGF of the aggregate would be Pn of Px. That means I'm going to substitute everything in. So 0.2 times everything would be 0.8 t plus 0.8 t squared plus 0.4 0.08 0.8 plus, there's some mistakes on that. It's I'm missing 1 0. So let's put constant first. Then we have 0.08 t plus 0.08 t squared plus 0.04 t cubic to the power of 9. Okay. So basically, in order to apply the result we have, we need to differentiate. But for the first one, we know the probability that s equals 0, it is nothing but the PGF at 0. So when you put everything in, you will get obviously 0.8 to the 9th, right? You can calculate the result if you want, but for SOA exam, you can keep this at the moment because this is not what we want. We want s equals 0, 1, 2, 3, 4. Right? We need to calculate 5 of them. And to calculate the probability at 1, we differentiate. Let's say the inside part is ft. So we put some notation for it. The entire thing within the round bracket, we call it ft. It's a polynomial function. So here when we differentiate, 9 will come out. Then the order becomes 1 less, that's 8. And then we need to differentiate the inside part for t, for ft, is 0.08 plus 0.16 t plus 0.12 t squared, right? And then we know the probability that s equals 1 would be the derivative at 0 divided by 1 factorial, which is 1. So we will get 9 times 0.8. Right now it's to the 8th, so 0.08. Of course, if you want, you can compute, but again, you can keep this number at this moment. Okay, next, we want to know the probability at 2 means we want to know the second derivative. Then you need to apply the chain rule. So things get more and more complicated because right now you have two terms, right? So if you differentiate, it will get 9 times 8. Order becomes 7, right? And this whole thing will get to be squared. And then by the chain rule, you keep the first term, then the second term becomes 0.16 plus 2 times 0.12 is 0.24t, and then you evaluate at 0. Remember now you divide by 2 factorial, which is 2, right? So you will get, so you need to continue. And we also need the probability at 3, which means you need to differentiate 3 times, and the fourth derivative as well, and then plug in the formula, right? So this will take well, some time, and that's given your calculation has to be correct. Here I offer you a different method. Okay, so let's offer a different method. We want to know the probability that s less than 4. So here n can be different values. So what you can do is to discuss for n. So let's say your big N equals small n. Then I want to calculate given the value is particular n. So here we have a binomial. So your n actually goes from 0 to 9. But of course, we don't need to discuss all of them. So here is the analysis. So first we analyze n equals 0. So when n equals 0, obviously s is 0, right? It's less than 4. So the second part will be 1. So in this case, the probability equals simply p n equals 0, right? Because the second part is 1. When big N equals 0, your s equals 0. 0 is obviously less than 4. It is automatically satisfied. So this part would be the probability that n is 0 and is a binomial, so its success rate to n. Okay, next, when n is 1, so your s equals x1. It can be 1, 2, or 3, right? 1, 2, 3 is one of the value. Either way, it's less than 4. So again, in this case, we know the probability is nothing but n equals 1. The second part is still 1 because s equals x1, and x1 can only be 1, 2, or 3. Any one of them is less than or equal to 4. So the second probability is 1 because it always holds. So we just need to figure out the probability of n being 1. That is 9 times this is 8. This is 0.2. So you can get the probability 0.302. So next is when n equals 2. In this case, your aggregate or our aggregate will be x1 plus x2. And we still want this to be less than 4. Then we need to analyze. Okay, when will we get this to be less than or equal to 4? For instance, if x1 is 3, x2 is 3, then we get 6, right? It's not what we want. So apparently in this case, it's not 1 anymore. So we need to actually discuss the case for the, this is twofold to be less than or equal to 4. There are many ways you can do, right? You can get the two-way table if you want, or you can directly analyze. Okay, so for instance, what you can do is for x1, you have 3 choices. For x2, you have 3 choices. So 3 times 3, you have 9 choices or 9 pairs for the value. You can easily analyze the probabilities. For instance, we want this to be less than or equal to 4, right? The smallest value, but you can easily analyze all the pairs, right? So which means when x1 is 1, x2 can be anything, right? So this means it's x1 equals 1. Okay, then we need to analyze when x2 equals 2, right? Then your x1 is 2. Your x2 should be either 1 or 2. Right, let's erase this. Okay, and finally, when my x1 is 3, x2 must be 1 in order to be less than or equal to 3. So let's compute the probability. X1 equals 1 is 0.4. So when x1 is 2 is 0.4 times 1 or 2. So I need to add them together. It's 0.8. So finally, when x1 is 3, probability is 0.2. X2 is 1 is 0.4. So it's easily 0.8. Actually, the easiest way is to look for the opposite, right? Because less than or equal to 4 is more complicated. We know when n is 2, your s is x1 plus x2. And the values ranged from 2, 3, 4, 5, 6, right? Those are all the possibilities. The smallest value would be 2, because that's when both x1 and x2 are equal to 1. You get the smallest value, right? So you can analyze. But here, if you study the opposite side, is 5 and 6, which is around the same level as 2, 3, 4, right? So you can analyze from the other side. So in this case, the probability would be n equals 2 and s less than 4 given n equals 2. So the probability for n being 2 would be select 2 out of 9 times 0.2 square 0.8. So here would be 7 times 0.8. So you can easily compute the result is 0.2416. Okay, then you can continue. Let me get one more page. So obviously you can continue this kind of analysis when n equals 3. Okay, now my s would be 1, 2, 3, right? So now I can easily see the smallest value would be with 3, right? When all of them are 1, 4, 5, okay, etc. I don't even need to actually care about the maximum. I only want the value to be less than or equal to 4, although we know the maximum is actually 12 when all of them are 3, not 12, 9. 3 plus 3 plus 3. But I only need to know this, right? So when do I get it to be 3? Given n is 3, is when all of them are 1, right? So that means when all of them are 1, 0.4. And when do I get it to be 4? Given this is 3. Okay, how do I get it to be 4? It is 1, 1, 2, right? So one of the value is 2, the other 2 must be 1. So there are different choices for this 2. This 2 can be x1, can be x2, can be x3, meaning I have 3 choices for 2. Okay, and the probability for 2 is I think 0.4, right? And probability for 1 is also 0.4 to the square. Okay, so what do we have? So now what we have is 3 times 0.4 to the to the cubic. Okay, you can easily now get the result if you have the calculator to compute everything. I actually didn't compute to this step, but you should be able to easily calculate. For example, 0.4 to the third is 0.064 times 4 is 0.256. Okay, so I will leave this to you. It's the probability that, let me write it out. Probability that n equals 3 and the conditional probability that s less than or equal to 4 when n is 3, okay? For at least for the first part, is you take 3 out of 9, 0.2 to the third, 0.8 to the sixth, right? And then you do the computation, you will get the result for the conditional probability, which is if you do the analysis, it's 4 times 0.4. Okay, so this is 0.256. So if you hit your calculator, what I get? Let me take a look. It's 0.0451. Okay. Next is when n equals 4, my s is x1 plus x2 plus x3 plus x4. Okay. This is already under the condition. So the smallest value is actually 4, right? The next one would be 5. So I only need 4, and 4 is when all of them are 1. So this is actually easy to analyze. N equals 4, PS less than 4 given n equals 4. So the probability that is 4 is easily written in this form. And in this case, all of them must be 1. So it's 0.4 to the fourth, right? If you calculate, this is about 0.0017. Of course, you can analyze when n is bigger than or greater than 5, then s would be at least 5. That is because the smallest value for x is 1, right? So if there are more than 5 claims and the size of each claim is at least 1, then the total would be at least 5. That is beyond what we want. We want s to be less than or equal to 4. So in this case, the probability is always 0, meaning if n is at least 5, there's no way your aggregate is less than or equal to 4. Okay, so finally, what we want is add all of those together, right? I think the final result is about 7246. In the second method, we can also modify a little. Let's call it method 3. Is you can actually analyze it one by one, meaning what is the probability that s equals 0? The only case this can happen is when n is 0, right? As long as there is a claim, your aggregate would be non-zero for sure. So this is 0.8 to the 9th. In order for s being 1, the only chance is when n is 1 and when x1 is exactly 1, right? If you have more than 2 claims, the minimum is 2. That's why this question is actually special. You can actually analyze, right? So for instance, the probability for n being 1 is basically take 1 out of 9, 0.2 times. Let me don't write x. So this is 8, right? X equals 1, 0.4, right? So next, let's analyze when my s would be 2. So then I have 2 cases. When there is 1 claim and the claim size is 2, or when I have 2 claims and each claim has size 1, right? So you can easily get the result. For example, C is 0.4 squared. There is 0.4, right? For this comes from the binomial. So now let's analyze s equals 3. So when n is 1, the loss must be equal to 3. When n equals 2, so it would be x1 equals 1 or x2, not all, is n. When this is n, x2 is 2, or x1 is 2 and x2 is 1, right? And finally, it's possible that I have 3 claims and all of them are 1, right? Finally, let's analyze the probability that s equals 4. I believe you can handle, right? So first of all, n cannot be 1. If n is 1, the maximum is 3. So we have to start with 2 So if you have 2, which means you have 2 claims, how do you get the sum to be 4? It can be 1 plus 3, or 2 plus 2, or 3 plus 1, right? The meaning is x1 is 1, x2 is 3, or x1 is 2, x2 is 2, or x1 is 3, x2 is 1. So when n is 3, then you can also analyze, right? That is 1 plus 1 plus 2, right? And finally, when n is 4, the probability must be x1 is 1, x2 is 1, x3 is 1, x4 is 1, right? So this question is actually not easy, right? But they test us everything. So there are different methods to solve this kind of question. Next one is 3.24. Aggregate can only take positive integer values. Okay, that's good. S minus 2, taking the positive is 1 over 6. This is 0. The probability that x equals 1 is 1/2. Calculate the mean of S. So the key is to realize this. What can you tell from this condition? If you know the aggregate can only take positive integer values, which means it will be 1, 2, 3, 4, 5, etc. And you have this S minus 3 taking the positive part, the expectation is 0. That means the probability that S greater than 3 is 0, right? Otherwise, this value will never be 0, right? So first of all, it's non-negative. And as long as you have some value that is greater than 3, let's say 4, then this is non-zero, right? So if, let's say, this probability is 0.1, then your expectation would be at least 0.1, not 0. So this tells us a lot of information, right? If there's no way that your S is bigger than 3, that means then your S can only be 1, 2, and 3. And we already know the probability that S is 1 is 1/2. Then we just need to figure out those two, right? Actually, one of them. So assume, or not assume, let this be theta, then the probability that S equals 3 must be 1 over 2 minus theta, right? It's a probability distribution. Adding all 3 probabilities, it must be 1. And obviously, we know this is greater than 0, less than 1/2, okay? So with this setup, let's use the other condition. When S is 1, this is 0. When S is 2, it is also 0. When S is 3, 3 minus 2 is 1 times the probability half minus theta equals 1 over 6. From there, we know the probability is 1 over 2 minus 1 over 6 is 1 over 3, right? So now we have all the distribution. We wanted to know the expectation of S, then it would be 1 times 1 over 2 plus 2 times 1 over 3 plus 3 times 1/2 minus this. Okay, so you can easily get the result, right? The final result is you can put everything to be 6. Then this is 3 plus 4 plus 3. So it's 10 over 6. So it's 5 over 3. This one is a little technical, right? The key is to really use this piece of information well. If you are able to get this step, the rest is actually easy, right? So the real trick part of 3.24 is to fully understand this piece of information. Okay. Next one. It seems that SOA likes this kind of question, right? They give you the well, you can think this as a deductible type insurance. Give you some information from there, and they want you to fully analyze this. For instance, we have two such identities, and the only possible aggregate claim in 20 and 30 is 22, and we know the probability is 0.1. The basic, somehow the difficult part of this question is to understand what this means. So let's draw a graph for CDF. So this is CD. We are trying to draw the CDF. So here is 20, here is 30. I don't care about the graph before 20. It can be anything. Let's just randomly draw a graph. This is at 20. Okay. Let's use a point to know this is 20. After 20 and before 22, there is nothing, which means it must stay flat, right, for this piece. And at 22, it has a single jump of 0.1. So this part is 0.1. Okay. Again, after this jump, it must remain flat until 30. Right? After 30, I don't care because I don't have the information for it. Right? So after 30, whatever the graph is, I don't know. I don't have information. Okay. This part is between those two is really the key. Okay. Once we have that, let's use this identity. Okay, we know this is from 20 to, well, let's put infinity. Sx x dx, right? And because this is an integral, I can separate it from 20 to 30. And then from 30 and beyond. Okay, by the way, this is the expectation of x minus 30 taking the positive part, right? So from this, we know this is the difference. The difference is 12 minus 8, so it's 4. Okay, now let's analyze this piece. If you want, you can use the CDF to convert, or we know, let me write it as this. Right, this is nothing but the definition, and then I will know this is not 10. This is 10 minus the integral from 20 to 30, the CDF equals 4. So which means the CDF part is actually 6. Okay. Then how do I use this information? I do integral from 20 to 30. We know for the first piece, from 20 to 22 is a flat part. Well, I don't know the value, but let's assume it's just the fx20 because that is the value, right, on this graph. So if I move to this, this is fx at 20, right? By the definition, let's say this is fx, or not x, s. Because we deal with the aggregate. So let me change. I think. So this part I need to erase. This is not s, so I need to change everything to s because that's what the question is about. Okay. So here's s, here's s, here's s, here's s, s. Everything's in s. Okay. Now let's do the integral, okay? So we know this flat piece is fx20. What about the other flat piece? It is fs20 plus 0.1 because I know there is a jump to the next level, and the size of the jump is exactly the probability mass. So I know I can separate this. Let me let me give you more information. So I can write this from 20 to 30. So, you know, for this piece, it's not a function, it's a constant according to this, right? So it's fs. I really like to write in s, x. So here's 20 dx plus from, here's 22. From 22 to 30, the value jumps up by 0.1. This is 6, right? So now it's very easy to do the integral. So here I have 8, right? So what is my fs? So 10 times fs 20 equals 5.2. So my CDF at 20 would be 0.52. Okay, so that's the result. What's the last one? The last question is 3.26. Aggregate losses follows a compound Poisson. So it's a collective model with parameter lambda equals 3. Individual losses take only 4 values. So it's a discrete distribution. Calculate the probability that the aggregate loss does not exceed 3. So first is the wording of the question itself. Does not exceed 3, which means I want it to be less than or equal to. So equality needs to be taken because this is not exceed, right? Which means it's you wanted 1 minus exceed, right? That's why, you know, what I'm looking for is less than or equal to 3. So here we have, well, you can do the same analysis as the same one as I did in the first question. We can so what I meant is n equals 0. Well, then obviously s is 0, so it's true. When n is 1, it would be 1, 2. Okay, so my x must be 1, 2, 3, cannot be 4, right? Then when my n is 2, okay, I have x1 plus x2, then it can be, well, different choices, right? So x1 is 1, then my x2 must be 1 or 2, cannot be 3, right? Or my x2, not x2, x1 is 2, then my x2 can only be 1, right? And that's it. Right? My x1 cannot be 3. If my x1 is 3, x1 plus x2 will be at least 4, right? So this is and when n is 3, well, then x1 is 1, x2 is 1, x3 is still 1. There's no other chance for me to get the summation to be less than 3. So now let's do the calculation. Then it's actually easy, right? So it's a Poisson distribution. So e to negative lambda to 0 is 1, 0 factorial is 1. So this is the first one. We know lambda is 3, so you can write 3 if you want. Lambda to the first, which is lambda, divided by 1 factorial is 1. So this is 0.4 plus 0.3 plus 0.1, 0.2. So it's actually 0.9 plus e to negative lambda squared 2 factorial times. Okay, now let's analyze. When x is 1, it's 0.4. x2 can be 1 or 2, so it's 0.7. When when x1 is 2, probability is 0.3. x2 must be 1, 0.4. That's it. And finally, I want my n to be 3. In this case, all of them must be 1. The probability of 1 is 0.4 cubic. Okay, and then get your calculator to get the result. It's about 0.2882. Of course, this is only one way of solving it, right? You can directly do the analysis for S. So let's call this method 1. You can use probability function, probability generating function, okay? Because N is Poisson 3, so you can easily write down the PGF, and X has this discrete distribution, which means I can easily write down the PGF for X, right? So 0.42t, 0.3 t squared plus 0.2 t cubic plus 0.1 t to the fourth, right? Okay, then from here I can easily get the PGF of PS, then I can differentiate, right? So this method is quite universal, which means as long as you can write down the PGF of both N and X, the implicit assumption is that your X must be a discrete distribution. Here is 1, 2, 3, 4. In the first question is 1, 2, 3. You can write down the PGF, then you can get the PGF of the aggregate. Then it's up to your calculus skill to decide whether you are able to solve this question. The other method I want to mention is you can directly analyze for each one of them. And it's not complicated, right? For instance, this can only happen when your N is 0. Because it's a collective model, right? As long as there is a claim, the aggregate would be non-zero, right? So this is just the e to negative lambda. And since the minimum size is 1, and if you want the total loss to be 1, you can only have one claim, and that claim must be size 1, right? And similarly, if you want 2, you can have one claim, and the claim is size 2, or you can have 2 claims, and each one has size 1, right? So similarly for this as well, right? If you have one claim, it must be 3. If you have 2 claims, one of them is 1, the other one is 2. If you have 3 claims, all of them must be 1, right? So, I already did the analysis, so why don't I write it down? So when N is 1, the only claim must be in size 3. So when N is 2, so it's either x1 is 1, x2 is 2, or x1 is 2 and x2 is 1. And finally, we have not N plus when N is 3, all my claims must be 1 and 1 only. Okay. We have one more question hidden down here. 3.27. This is actually an easy question because we know you have a compound model, so it's collective. Right, so S looks like this. The claim frequency has mean, so we know mu n is 100, sigma n is 25, and claim severity is 20K. The standard deviation is 5K. We want to apply the normal approximation to calculate the probability that the aggregate loss exceeds 1.5 times the expectation of loss. Okay, so in order to apply normal approximation, we would like to know the expectation of S, which is simply mu n times mu s. We get this to be 2000 K. So it's 2 to 6. We need to know the variance. variance is mu n times sigma x squared plus expectation of x squared times the variance of n. You can easily calculate from there. You actually need to take the square root. You get this to be about 502,493.8. Okay. Finally, we want to know the probability S is greater than or equal to 1.5, the expectation of S. So let's use mu, okay? So it's since I use mu S. So we do the normal standardization. So this would be 1.5 mu S minus mu S divided by sigma S, right? So you can quickly do the computation. This is about 2 or 1.99. So it will be 1 minus the number you get from the table. So it's very small number. That concludes the SOA question part. So let me stop my video here.